Hey guys, welcome to the channel Learn Competitive Programming with CodeChef. So if you are new to the channel, then this channel brings a quality content on data structures, algorithms, some concepts of competitive programming and video editorials for the CodeChef contest. So new to the channel, then do subscribe channel and turn on the bell notification. Myself Chirayu Jain, I'm a CodeChef educator, and the problem in the series of linked lists that we're taking today is linked list 2. So let's start understanding the problem. Okay guys, so now let us understand the problem that is linked list 2 with the problem code LL2, right? So let's read the problem statement here. So the link to the problem is in the description as usual, so you can find it there. So let's start with the problem. You are given two sorted linked lists, right? Merge the two lists such that the final result is also a sorted and return the head of the merged linked list, right? So the function takes two arguments, head of the two linked list, and you are expected to return the head of the merged sorted linked list, right? So there is also a snippet available here. So when you click the submit, the snippet will come and we need to just write the logic inside that function. What this function takes is given there, that is two heads of the two sorted lists, and we need to merge them and make a single sorted list, and then we'll return the head. So that's all what is required here. Input, as we can say, there are number of test cases. N and M are the lengths of two linked lists, and these contains these nodes from 1 to N and 1 to M. So we do not need to care for that as of now here, because we need to just only complete the function. We can submit the code in any language you want, like Java, C++, Python, primarily used languages, and the output that we need to return is, as expected, the head of the merged sorted linked list. So here if you see the test cases, that we have two lists here that is of length 3 and 3, 1 2 3 1 2 3, and we need to return the head. So when we combine this, so what will be the sorted list that we can encounter? 1 1 2 2 3 3, and we'll return the head which is pointing here in the function. Similarly, for the second test case, we have only single list, that is 2 2 3, and it is we have two lists, that is 2 2 3 and of length 1, right? So you have the lengths given, and when we combine them, so the output will be 1 2 2 3, right? So this is how we are taking the input and presenting the output. So hope the question is very clear. Just two sorted lists we are given, and we need to combine them and make a single sorted linked list. So this question resembles something the code that we are doing in the merge sort, right? So we have two arrays, and we need to combine them to make a bigger array, and which is sorted, right? So some core concepts of merge sort and the concepts of linked list, will combine them, and then we'll form the solution of this particular question. So let's start off with the approach. Before that, if you have some idea, if you're getting some initial instinct while reading the question, then please try this question on your own and try to submit it. Otherwise, you can see the approach and the code. Let's start with it. Okay, so now let's start with the discussion of this particular problem. So let us take an example and see what all possible cases can we find here, right? So we need to combine these two linked lists. So here are the two linked lists. This is linked list 1 and this is linked list 2, and we need to create a linked list 3 with the combination of these two linked lists in a sorted manner. So as you can see, these two linked lists are in the sorted manner, so the final should be also in sorted manner. So how we can do this? So the core concept of merge sort, what we used was that we need to combine these two things. These two things are sorted, and we need to combine this. So what we used to do, we used to have two pointer type structures which is used to keep track. Okay, if this is smaller, then take this and move the pointer to the right hand side. This is smaller, comparison of these two values and take that particular value. So how we can do this is, let's see. So we'll start from the beginning of both the linked list and compare the values. 2 is less than 4, so that means ideally 2 should come at first position in the linked list. Why this thing holds true here? Because both the linked lists are sorted. So that means we cannot find any element in both of these linked lists greater than the pointer elements, right? We cannot find any elements which is smaller than this particular element in the right hand side of the linked list, right? So this condition holds true because these are sorted linked lists, right? So let's try and understand. So if in this particular case 2 is less than 4, right? So we'll keep 2. and what we will do, we'll increment this pointer from here to the next point, right? So it will be now here. Then again we'll compare the values from the linked list 1 and linked list 2. Okay, 3 and 4. So 3 is less than 4, so we'll take 3 and increment the pointer, right? So now the pointer will point into this. So that's what we did in merge sort. If you have seen the merge sort video, then you should relate that, right? And if you've not seen it, so you can see it in the series of sorting videos, right? So now when we compare 6 and 4, so obviously 6 is greater than 4, so we'll take 4, right? And we'll increment the pointer in the linked list 2. 5 and 6 comparison, so 5 is smaller, we'll take 5 and pointer is incremented at 9. 6 and 9, which is smaller? Obviously 6, so we'll take 6 and increment the pointer. 7 and 9, which is smaller? Obviously 7, so we'll take 7 and increment the pointer. But now as we can see, there is no element left, so the pointer will be pointing to null. So here will be the pointer, right? So now what we will do, is this our answer? No, because the elements of the linked list 2 are remaining. So we'll check that if one of the linked list is full, then the remaining elements we will take from the second linked list. That means 9, 12 and 13 will take it from the second linked list. We'll keep a check over this, right? So whenever we'll get out when one of the linked list is full, then what we will do is we will take the remaining elements for the rest of the linked list. So now the answer will be like this: 2, 3, 4, 5, 6, 7, 9, 12 and 13, right? So this will be the final answer. So that's how typically we can solve this particular problem. This question is easy, and implementation wise also it is not very hard or something like that. So let's quickly see the implementation and run the code on the CodeChef platform. Okay guys, so now let us implement the code here in this particular snippet. So we have been provided with the function merge and the head1 and the head2. Let's try to implement a logic, right? So what we will do, first of all, we'll create a node that is current node and initialize it with null, which will keep the track of the current nodes that we're entering into the linked list, and one which will be the head, right? So let us say that is final, and we'll also initialize it with null, that we will return at the end, right? So these are the two things, and we'll make a condition while head1 is not equal to null and head2 is not equal to null, will continue, right? This is the first thing. So we'll enter into the loop while both of them are not null, right? Now what we need to check, that if head1 data is less than equal to head2 data, then what we need to do, right? So if this condition holds true, then what we need to do, firstly we should check that if final equals to null. If final is null, because final is carrying our initial head, right, initial node. So if final is equal to null, that means there is no node in the linked list. So what we will do, we will initialize final with our head. Sorry, so here I have written head.data, instead it will be head1, right? So we'll initialize final with head1, and current will be also equal to head1 because it is the first node, right? Otherwise, if it is not the first node, then what we should do, that means there is some node, right? So there is some node, that means current is moving, right? So current dot next will be pointing to head1, and we will modify the current also. We'll make current equal to current dot next, right? So this is what we will do for current. Also we need to modify head as well, because we have encountered that okay, this head1 data is less than equal to head2 data, so we need to increment the head pointer as well. So we'll make head1 equal to head1 dot next. So this is the whole case where head1.data is less than equal to head2.data. Same thing we will replicate for our head2 as well, right? So I need not to write the whole logic again and explain. So I will simply copy this from this if condition till here, and will write it over here, and just make the changes for the head1. Instead of head1 it will be head2, right? Head2, because the same thing will be replicated for the head2 as well, right? If head2 is less than head1, right? Okay, now the condition comes for whether if the linked lists are fully completed or not. If one linked list is fully completed, the other can be remaining, right? So what we should do, we should write the condition for it, right? We should write the condition for it. So how we can write this, that if head1 is not equal to null, that means there are some values remaining. So what we will do, simply we will make current dot next equal to head1. If head2 is not equal to null, simply what we will do, we'll make current dot next equals to head2. That way the remaining values of any of the linked list will be taken care of, right? And at last what we will return, we will not return current, because current is traversing. We will return the first head of the particular linked list. So what is the head? That is final. We will return the final, right? So typically this is the code for this particular thing. So now let's try and just submit this. And we got AC.